Identifying factors influencing medium-density fiberboard production from Young Eucalyptus grandis, E. amplifolia, Corymbia torelliana and Cottonwood. By Donald L. Rockwood, Gerald E. Wynandy and Neil R. Gribbins. The primary objective of this study was to evaluate and compare the broad suitability of Young Eucalyptus grandis W. Hill X. maiden, e.g. E. amplifolia northern, E.A., Corymbia torelliana, F. Muel, K. D. Hill and L.A.S. Johnson, C.T., and Populus deltoides W. Bartram X. Marshall, P.D., for making MDF by evaluating the basic wood properties of MDF produced from defibrillated short rotation woody crops, SRWC. Fast-growing e.g., E.A., C.T., and PD may be deployed in SRWC systems in the lower southeastern USA, especially in Florida. To evaluate these species for possible use as medium-density fiberboard, MDF, and other composites, 2.5 m logs of 3 EG clones, 3 PD clones, 6 EA progenies, 4 CT trees, and 1 P tremuloid semics. PT tree from northern Wisconsin as a control were characterized for basic wood properties before being chipped, pulped, and pressed into MDF. The chips were thermomechanically pulped, TMP, for a two-phase study of the factors expected to influence suitability for MDF production: wood characteristics, refining system, resin system, and MDF formation. Phase I used TMP and 4% phenol formaldehyde, PF, resin to produce 17 MDF species genotype batches, SGB. Thickness swell, TS, water absorption, WA, internal bonding, IB, modulus of elasticity, MOE, and modulus of rupture, MOR, were evaluated to 1. Assess within species and within tree variation, 2. Relate basic wood properties to MDF potential, and 3. Examine repeatability of MDF making. There was considerable variation among and within species, but only minor variation within individual trees. The analysis also examined the effects of species, genotype, and/or log on MDF panel properties with a significance level of 5%. Species and SGB means were tested using Duncan's multiple range test. 6 of the 17 SGBs had superior physical and mechanical MDF properties. In Phase 2, 2 of the 6 better performing Phase 1 SGBs were evaluated, along with 3 average Phase 1 SGBs. Phase 2 compared the effects on IB from using tube and drum blenders for resin application, the influence of using unscreened versus screened fibers, and the differences between using PF resin at 4% or 6% versus urea formaldehyde, UF, resin at 8% or 12%. Overall, genetic variation among species, and particularly within these species, affected their potential for commercial MDF. Log-specific gravity, SG, fines, MDF-SG, and fiber length influenced MDF properties, as did refining and MDF processing variables. Further study of specific processing requirements can optimize the potential of young EG, EA, PD, and CT genotypes grown as SRWCs for MDF and many other wood composites. These results are encouraging for the development and use of wood composites from SRWCs in Florida, the southeastern USA, and elsewhere.
Thank you for watching this video. Please subscribe
subscribe our channel for watch more scientific research videos.